Here we are looking at altitudes of celestial objects relative to the horizon. We begin with a view of Earth from space. We see here this circle represents the Earth, and this line here is the axis of rotation of Earth, and if we extend it out toward the celestial sphere, we see that it would intersect the celestial sphere at what's called the North Celestial Pole. And very close to the North Celestial Pole, but not quite on it, is a star called Polaris, and Polaris, or the North Star, we can use that as a guide. So it's not quite on the North Celestial Pole, but it's very, very close that we can use it as a guide. Now, perpendicular to the rotation axis is the equator on Earth, and we can see that the rotation axis is inclined relative to the perpendicular to the orbital plane of Earth by an angle of 23.5 degrees. So this angle is 23.5 degrees, and this angle is also 23.5 degrees. For a person on Earth, the angle between the equator and the location of the person on Earth is called the latitude. So here we're calling theta the latitude of the person. So if we look at a view of the sky in the northern hemisphere, so if this is the northern horizon and this is the southern horizon, then if a person looks in the direction of north, above, at an angle of theta above the northern horizon, that person would find Polaris, or very close to the North Celestial Pole. And this angle, theta, coincides with the person's latitude. So as seen from the surface of the Earth, the altitude in degrees here of Polaris above the northern horizon is the person's latitude. Now, we know that the direction to the North Celestial Pole is along the axis of rotation of the Earth. So perpendicular to that, or 90 degrees from that, we would find a line pointing in the direction of the celestial equator. In other words, the equator of the Earth projected out to the celestial sphere intersects the celestial equator. So if the altitude of Polaris is theta, then the altitude of the celestial equator relative to the southern horizon would be phi. Call this angle phi. If we look at the relationship of these two angles, these two altitudes, we can say then that theta plus 90 degrees, which is the angle between the North Celestial Pole and the celestial equator, plus the angle phi, which corresponds to the altitude of the celestial equator, that should give us 180 degrees. Or we can simplify and say that theta plus phi equals 90 degrees. The altitude of the North Celestial Pole plus the altitude of the celestial equator gives us 90 degrees. Now, let's look at the inclination of the axis of rotation, how that affects our seasons. So the equinoxes, which occur on or about March 21st for the vernal equinox and on or about September 21st for the autumnal equinox. Equinox means equal nights. So if we see here, the sun is off to the right here, we see that this hemisphere to the right is the day side, and the hemisphere to the left is the night side. And we see that every point on the surface of the Earth is going to receive 12 hours of daylight and 12 hours of darkness. So as seen from Earth, the view of the sky, and this is in the northern hemisphere, we have then that during the vernal and autumnal equinoxes, the sun is crossing the sky along the celestial equator. So if we identify the North Celestial Pole, Polaris, and we identify the celestial equator, the sun is going to be on the celestial equator on these two particular days of the year, the vernal equinox and the autumnal equinox. If we look at summer solstice, which occurs on or about June 21st, we see that the axis of rotation is tilted in the direction of the sun. And if this line separates the day side from the night side, then we can see that for persons on the equator, they will always be receiving 12 hours of daylight and will also have 12 hours of darkness. But in the northern hemisphere, this is the longest day of the year, and so we can see that there's a large arc here of daylight and a small arc here of darkness. So it is on June 21st we have summer in the northern hemisphere, but we have winter in the southern hemisphere. 6 months later, when the Earth is on the other side of the sun, then the axis of rotation points away from the sun, and now in the northern hemisphere we have the winter solstice, which occurs on or about December 21st, and that's the shortest day of the year. And conversely, the longest night of the year. So the view of the sky in the northern hemisphere then during the summer solstice and the winter solstice. During the summer solstice, the sun crosses the sky 23.5 degrees above the celestial equator, and during the winter solstice, it crosses the sky 23.5 degrees below the celestial equator.